sometimes we're interested in the variation of the prediction, the variation of the estimates. How do they vary? Is that likely that if we give a prediction for something that that prediction is going to be there's going to be a lot of variation in that? To just get that estimate, we have a few statistics that we can measure. We can measure something called sigma squared, and that's the estimation of sigma squared, where sigma squared is the variance of the error term. Just to give you an intuition, if we go up, we mean just how away on average are the points to the plane. How if the plane is the prediction, then how off do we think or do we estimate that those points are going to be? That's why this estimation of sigma squared is important. The variance is estimated by MSE. MSE is also called S squared in some software, or S of y given x. There's multiple notation for this, but MSE is probably the most common one. MSE stands for mean squared error, and it's just the sum of the squared errors as a C. We have seen this before, so it is the actual minus the predicted squared, and then we sum all of those errors divided by the number of by the degrees of freedom of the errors degrees of freedom, which is n minus k plus 1, where k is the number of predictors. So if we have, let's say, two predictors, 2 plus 1, because we have to estimate the y-intercept, in other words, the number of beta parameters, which is one slope for h, one slope for the square footage plus the y-intercept. That basically, in this case, we have, let's say, I think it's 42 ohms. So that's going to be 42 minus 2 plus 1, minus 3, which is what we get here in 39. That's the error degrees of freedom. So SSE, which we found under sum of squares residuals, is this value divided by 39, that's 52.01. That's MSE. That's the estimate of the variance of the error term. In other words, we estimate the variance around the regression plane to be exactly that number. That's the estimation for that value. Now that's in square terms, so sometimes we prefer to take the square root of this value, and the square root of these values are MSE, stands for root mean squared error, and that value is given under the output, and it's that residual standard error. So if you take the square root of MSE, you're going to get these RMSE values. Again, I can add a code cell and then take the square root of the 52.01, and if you just run that, you're gonna get the exact value for the residual standard error, which is RMSE.